Hey, YouTube. Hey, Charlie.
Hey, thanks so much for having me on.
Yeah, it's great. Good to have you here. Everyone out in the audience, please let me know if you got questions, thoughts, comments. And with that, let's go ahead and kick it off. Charlie, welcome to Talk Python to me.
Thanks so much. It's my pleasure to be here.
Yeah, it's a pleasure to have you. We're going to talk about making Python code fast. Built some pretty interesting tools here with Ruff, and we'll see about integrating Rust into Ruff, and some of there's a lot of cool tools around this sort of code quality side of things, right? Like Black took off in ways I think even that Lucas didn't maybe imagine it would take off, and this is kind of in that same realm, and of course, and
Exactly. Yeah.
plays well with Black along the way as well. So we'll get to talk all about those things. It's going to be tons of fun to dig into them, but before we get to it, let's start with your story. How'd you get into programming in Python and Rust?
Yeah. So I got into programming, I guess, the summer before I went to college, when I guess I was supposed to be like doing something fun. I taught myself Java, and it was the sort of thing that a lot of people had told me I would like, but I never really had a chance to dig into. I ended up, I went to school, majored in computer science, so did a bunch of internships while I was in college, and then when my sort of junior year internship in my first year out of school, I worked at a company called Khan Academy, which is like an education technology company. And at the time, this is less true now, but at the time they were a really big Python shop, and they had one of the biggest like app engine deployments. It was like Khan Academy and like Snapchat and like a couple other maybe
I had no idea.
or someone.
I'm familiar with Khan Academy, KHAN. I'm sure a lot of people are.
Yeah.
But I didn't realize that one, they were such a GCP customer, and that was Python.
Yes.
Was that Lasker or Django on GCP, or what was it?
It was like Flask on App Engine. Yeah, we did not use Django. But they actually, I mean, it's a whole nother story, but they did a big Go rewrite after I left, which is also super interesting. I mean, it's not Python, but it is still very interesting. Just like migrating a system that big from any language to any other language is always pretty interesting. But at Khan Academy, I did some Python. I would say that like I mostly did web, and we can talk a little bit more about this because like really through my career, I've kind of jumped between a lot of different ecosystems. And so like at Khan Academy, I did, I think, a year of Android, and did a little bit of iOS, did a lot of web, did a little bit of Python. And then most recently, I worked at a company called Spring Discovery, which is like a computational biotech company. And everything we were doing was based on computer vision. So we'd like take really high resolution pictures of cells and then try to model like the way that they change when you add drugs.
Wow. Okay.
Which is, yeah, it's pretty wild. I mean, I came into that with no
That's awesome.
bio background. I joined as like the second engineer and built out a lot of our like data and machine learning platform. So that was kind of a crash course in building like a massive system in Python, right? We were doing scientific computing, so it made a lot of sense to use Python. So we ended up using Python for like almost everything.
Python's a really good choice for the web, but it's like the de facto choice for data science, right? Like
exactly.
There's not a whole lot of other choices. Whereas on the web, there's 5 or 6 other platforms and languages that are also contenders for that space, right?
Right. So we built out I mean, what I consider to be like a fairly large Python code base. It was like a big monorepo. And I spent, I can't remember, I don't know, 4 or 5 years, building that out and like really writing a lot of Python every day. That's where like a lot of my Python experience comes from. And like that experience specifically also informed a lot of Ruff. And I can talk more about sort of how those experiences intertwined, but that's kind of my Python background.
It must have been really fun to explore some of this visualizing cells and interacting with microscopes and
it was amazing.
all those kind of things.
the coolest part of the job was just that, you know, like if you bucket it like really crudely, like a third of our team were sort of like software engineers or like data scientists, machine learning researchers. And then, you know, a third were like, you know, wet lab biologists, PhDs, you know, and so every day I was like working directly with scientists and like building software for scientists, which was just like a super cool thing to be able to do as, you know, part of a small team. But yeah, wrote a lot of Python.
That's awesome. I worked at a place that was a bunch of PhD researchers doing eye tracking, like not Apple, but your actual eyes, like what are you looking at? Wrote the software to actually control the device and get all the information off of it, and then like analyze that and put, you know, generate like reports for the scientists and stuff. And there's a special kind of cool for software that touches like reality, right?
Yes. Yeah. Yeah. I mean, it adds a lot of complications.
Of course it
is very cool.
You don't get exact numbers. You want to test it, like you got to approximate all the things, but still, yeah, that sounds like a super fun job. How did it inform Ruff? Like, what are some of the experiences that?
Yeah, totally. So
came over. Maybe, hold on one second before we, just so people know, Ruff is like a super fast linter. Just give us the quick elevator pitch so they know what the heck Ruff is. We'll dive more into it later.
Sure. Yeah. So Ruff is what I call an extremely fast Python linter. So if you've used linters in Python in the past, you've probably used something like Flake 8 or PyLint, or maybe like PyCode style. You know, maybe use other tools to help manage your code style, like Black or like Autopep 8. All this stuff that deals with effectively code style. So Ruff is a linter. It looks at your source code and it tries to report back and tell you, sort of flag and tell you about issues with it. And those could be stylistic issues, like this variable name is not great, or they could be, you know, like logical issues, like you reference a variable here that isn't defined.
Right.
And you know, I think there's a lot that distinguishes Ruff, but like the thing that I think caught a lot of people's attention was just how fast it is. So I sort of hate benchmarks, like, because no matter how much time you like put into a benchmark, like it's always wrong from like a certain perspective, and like people always complain about them. But
right.
I think Ruff is comfortably like somewhere in 10 to 100 times faster. Some people even say like 1,000 times faster on their setup. So it can be like really, really dramatically faster. And it can also do a lot of auto fixing, which is kind of a distinctive feature that I don't know that many other tools. There are certainly tools that do code transformation in Python, but like PyLint and Flake 8 and such don't do this. So for lots of the errors that Ruff will flag, it can actually fix the code for you and fix the issue for you, which is a big time saver.
I don't know if this is one of them, but just to give people an idea. Like one of the errors or warnings rather that it'll give you is you have an Fstring, but you're not leveraging its Fstring capabilities, right? I'll just say F quote, and then it has just static text, a literal string. So it doesn't need the F, right? Theoretically, you could say Autofix and it drops the F for you. It's like, yeah, you don't need that, right?
Yeah, and you know, we can also like go the other direction. So like if you're doing a bunch of like % string formatting, or you're using like the dot format style helpers, we can fix at least one of those right now. Strings are really complicated, but like we can actually rewrite, I think, the dot format calls into F strings, which is cool. Right. So, fantastic. You know, another thing we can do is we can kind of keep your code like modern in a way. We've taken a lot of inspiration from other tools, like PyUpgrade too has like so much cool stuff and functionality in it if you haven't seen it. And we take some of the rules from PyUpgrade and basically re-implement them in Rust and package them into a single interface in a single tool. So you just install one thing and you get, you know, 370 something rules.
Yeah, I can assert that it is indeed fast. We'll dive into a little bit later, but I ran it on Talk Python training, the courses website that I have. And I think that's got 20,000 lines of Python, and it's it's instant. It's like you press enter and then out, the stuff is just printing out. These are the things it found, which is it's pretty awesome. So back to your data science work. How did what you're doing influence your creation of Ruff? Like, why not just use Flake 8 or something like that?
Well, we did. So like, or sorry, in that role, like I said, I'd like worked in a lot of other ecosystems where with sort of like stricter languages, right? Like Java and whatever else. It's not to say those ecosystems are better, but I often come at this stuff from a perspective of wanting a lot of like static analysis tooling. So we had like a really heavily typed code base. We used MyPy. We used Black. We used Flake 8. We used iSort. We used what else? I don't know, like doc formatter. There's like a lot of different stuff that we used. I was, really my job was like, I was the maintainer of this big system, and like a lot of people in the team were effectively like clients of that code base. So they were kind of like using the stuff that, I and some others were building as like a library. And so I had to maintain like this really big system. And like the more static tools you have, in my opinion, it just like greatly increases the leverage that you can have as a maintainer. So we use a lot of tooling. And I think like a couple things happened. One, I was spending a lot of my time in Python, but I was also doing a lot of web. And so, like 1 week I'd be doing Python, the next I'd be going and doing like React and TypeScript and whatever else. And so people complain a lot about web tooling, and like, there are certainly lots of valid complaints about it, but there's been a lot of interesting innovation, I think, in that space. And I was certainly influenced by some of it, just seeing some of the tools that came out and how fast they were.
Sure.
And the fact that a lot of those tools were not being written in JavaScript sort of intentionally to make them super performant was pretty interesting to me. So like, I don't know, I don't want to like name drop a bunch of tools, but in the web ecosystem, more tooling is being written in like Go and Rust and even some other sort of more out there languages like Zig. And to me, that was kind of an interesting thing. It was like, well, does the Python tooling have to be written in Python? Like, why does that have to be the case? And like, what does it buy you and what do you lose? So that was one thing. The other was we actually started to do a lot of Rust Python hybrid stuff in our own code base. Our code base was fully Python, and over time, we took some of the like really performance critical pieces and started to rewrite them in Rust and expose them to the Python side using some of these like really great Rust Python hybrid tools that, maybe we'll get into later. So like one example is we were dealing with image data. So like a common thing we had to do is just like download a lot of image files like really, really fast.
Right.
And so we wrote that in Python. We wrote like a bunch of versions that use all sorts of like multiprocessing and like threading, and like we tried everything. And then eventually we like rewrote it in Rust. And so we had a really simple, Rust module that would just download files really fast. And we exposed that as a Python API. So like from the Python code, it just looked like Python, but the actual code that was running and the way it was, built and executed all went through Rust.
Right. So you have these big data or let's say big computation problems where you're like, this could be better. At the same time, you're looking at this happening on the web side, Webpack or whatever it is. And it's like, this is way better. We can do this in Python, but we aren't. So, let's start, right. Probably you got a little experience there and you're like, what else can I build with Rust now that I know how?
Yeah. I mean, I think like, I was seeing, the way that this innovation was happening in the web. I was seeing specifically the Rust Python like opportunity from what we were doing. And then I was, frankly, like feeling a fair amount of frustration just with the performance of a lot of the existing tools. Like, I don't know. I'm always really careful with how I talk about this stuff because I hate I'm really like not a hater. And like, I've actually gotten like so much value out of like all of those tools. But I was being like, well, should it really take like 1 to 2 minutes to lint my code? Like, couldn't it be much faster, right? Like, it's like a big code base, And like as you add more plugins and everything else, it really like changes like how you feel about the tool, right? It's like it's no longer like something I just run and get feedback. It's like, oh, I have to run the linter now. Oh, I have to run the blah, blah. And I was sort of craving that.
Yeah, and if you're doing it on a team, my experience at least has been some people in the team continue to run it because they find more value than stress, and others are like, I'm not running that stupid thing. But then their problems get pushed onto the people who still care, and so then it creates this kind of like a tension, like, oh, you know, Joe's code is always kind of crappy because he won't lint it. But then like when I check out his code, my stuff starts reporting, like those are the weird dynamics that happen from tools that are like super slow unit tests or super slow linting or those types of things where certain people stop working with them and others don't. And then you get these weird tensions. So having it fast, there's like real value to that.
Yeah. I mean, and I think for me, like, I left Spring in like mid to late August. And I started working on Ruff along with like a couple other projects, and I never built a linter before. So like I didn't really know what I was doing, but it felt, maybe this is like a little bit of hubris or not, I guess, because like it seems to be working, but like I was kind of like, I'll start with a linter because it feels like a tractable like scope of problem. I was like, type checker, I know that's hard and like I don't really know much about it. A linter, I feel like I could learn like some of the concepts. I have a good understanding of like how it might work. And
to me, when I look at it, I think linting people's code, like abstract syntax trees and stuff, I'm like, that doesn't sound like an easy problem to me, but it's good that you saw it that way.
I learned, get through it. Well, the first version I released was like very limited. It was sort of, I sort of needed to get it out because I wasn't sure that people would actually really care that much about like what I was doing. Because like I've described to you a lot of like pain points. They're also sort of like opinions, right? But like, I wasn't like a faster linter, like who cares? Was sort of, I wasn't sure. So, when I released it, I was like, I want to prove it's possible. I want to like have reasonable confidence that the performance won't get worse or much worse as I expand it. But I only supported like, I don't know, maybe like 20 rules, which was fine with me because I was really trying to prove a point more than, get people to adopt it even.
Right. Well, and a lot of times going through that experience, even if very few people used it, you learn fantastic things, right?
Yeah, I learned so much. And I read a ton of code. Like I've read like a lot of source code now. So I've read like all of like, PyFlakes, like PyDoc style, PyCode style, like, because I've spent time like trying to re-implement a lot of those rules and like understand how they do things. And you just learn a lot from like reading and trying stuff. Rust is sort of like a whole nother thing where, I did some Rust at Spring, but I would say that building Ruff was really like my Rust learning experience. I think I had to kind of try to build something from scratch to like really understand the language. Like everything.
You do all the tutorials.
I was, and I was
you do all the tutorials you want, but sorry, go ahead.
No, I just like, I didn't do the initial Rust migration at Spring. I worked with another like super talented engineer who did that. And so every time I went into, and I made a bunch of changes to it, but every time I was going in and out, I was like, I just need to like ship this and like move on. Like, I'm not going to spend a bunch of time like really understanding everything that's going on here. I just want to get it to work. And so I needed to like sit down and like really like focus and be presented with like a blank slate, I think, to learn and just like fail a lot and like build stuff that didn't compile, right? And like figure out how to resolve those problems. It's honestly, it is a tough learning curve.
Yeah, I'm sure that it is. I started out in C++, and so I know there are harder languages and there are easier languages. So
I've
Eddie,
never written a line in C++.
You're not missing that much, I would say. Eddie, out there says, Ruff is so awesome. I actually changed all the switch statements in my Python 3.10 code back to if else blocks so I could switch to Ruff, which is
wow.
It's pretty awesome.
That's super nice and slightly embarrassing because we don't support match. We don't support match statements.
Don't support the match.
That's the one. That's the one big language feature that we don't support yet.
You could just kind of comment it out, like we're gonna just ignore whatever's in the switch. It must be fine. On to the next part.
Yeah, exactly. Right.
yeah. I mean, not for your code, but for linting. And then maybe let's start our dive in with this comment from Tyler, who says, "What are the differences between linters like Ruff and Flake8, those versus code stylers or formatters like Black?" And maybe Ruff lives in the middle of that spectrum. I'm not sure.
Yeah. It's certainly like you said, it's like a spectrum, right? So I guess there's a couple of different ways to think about it. And with those tools specifically, like some of the responsibilities have, like in my mind at least, shifted a bit over time. So for example, like Flake8, it does a lot of, it doesn't change your code at all, and it'll just tell you about issues. And those issues could be style issues, like you have extra white space here, or I don't know.
Your lines are too long.
This line is too long. But it could also be like a logical issue, which is something that Black wouldn't touch. So it might be like this import is unused. So on the one end, you have like, different collections of rules and maybe not really changing the code, just kind of telling you about it. Black is different in that Black just reformats your code. So it's not actually aware of like the logic in the code. Like it doesn't know that an import's unused. It doesn't know that a function is never called. It just takes, that abstract, well, not exactly the abstract syntax tree, but it basically preserves your code as is and just tries to restyle it. And so, it's interesting because like if you use Black, you probably don't need a lot of style linting. Like if you're using Black to format your code, a lot of the rules in Flake8 aren't that relevant anymore.
They'll say something
not
like
all of them,
they'll say something like you should have followed the rules of this, but Black automatically follows those rules for you, right? So they're kind of you don't need to correct the line length because Black will wrap it because that's what Black does. Right.
Yeah, or even like if you have like x equals 1 with like no spaces between the x and the equals and the 1, like the linter will yell at you for that, but Black fixes that for you. So a lot of people will turn off those rules. This is why I say the responsibilities have shifted a bit over time. I think you're right that Ruff, like it kind of sits in the middle. We do less stylistic linting for this exact reason. Like I use Black a lot. Black is like immensely popular. So I actually heavily deprioritized like all of the stylistic rules that are made redundant by Black. But the difference is we do a lot of that automatic fixing. So like we can remove unused imports for you. We can even do like a lot of more complicated rewrites. Like if you're using like a dictionary constructor, like the actual, DICT parentheses arguments, we can actually rewrite that as a literal. If you have the rules enabled and you want to do that, there's like a bunch of rules around like comprehensions and literals, and we can do those rewrites too. It can do like style and reformatting, but it's somewhere in the middle.
Yeah, the fact that it makes some changes, but it doesn't go completely all in like Black is kind of why I think it lives a little bit in the middle there. One of the things that I think might give people a lot of, what's the right word? A lot of faith or willingness to give it a try is there's a lot of projects out here that are large projects that people would know that have actively adopted and started using Ruff. I saw a quote from Sebastian Ramirez from Fast API. Right now in the audience, we have Olfek says the next release of Hatch, which I hope to do this weekend, will have all the new projects generated with config for a linting environment that uses Ruff, which I think is pretty excellent. Maybe speak to some of that, like about these projects adopting it and how that's helped you.
Yeah, totally. I mean, yeah, I never expected this. Maybe that like goes without saying. I think you'd have to be like super arrogant to release something and expect a bunch of these people to use it. It's been kind of wild. Initially there were a couple big projects that I would call like really early adopters, and they helped shape the project a lot. Like Pydantic was a very early adopter. Zulip was a very early adopter. Fast API was actually like a pretty early adopter too.
Okay.
And then like Pandas and Airflow and stuff, those kind of are more recent.
Okay.
I think it's been very interesting, like, to reflect on how that's happened, because on the one hand, it's like sort of ridiculous that all these projects would migrate over because I don't even really have like a proper versioning system right now. Like I'm on v00225 or something. I basically release like every day. And I consider like, we've made like very few breaking changes, but like in theory, we could make breaking change. I don't want to, but like, at least if you subscribe to Semver, like we could make changes like that. There's not really like docs. Like the docs are just like this huge README. So like it's kind of wild, right? We don't support like all of the Python 3.10 features, right? We don't support match statements. So on the one hand, it's kind of wild that all these projects would move over. I think there are a couple things that helped a lot. So one is that the entire time I've been like very, very focused on compatibility with existing tools. And that comes at a lot of cost. Like if there are things that I like don't agree with, right, or whatever else, like I sometimes still support them or implement them. But the upside is like it's very easy for people to migrate.
Right. Like it might change nothing potentially, right? It just goes faster.
Yeah, hopefully. And over time, like we don't have like a third-party plugin system. We've just like implemented everything like in Rust, like as part of Ruff. And I viewed that as like, I'm just going to look at the most popular plugins and the most important rules. And I'm just going to figure out like, what's a blocker for whom? And like, what do I need to implement in order to like unblock people and like make sure they can use it?
Is there a way for people to let you know which of those are really important to them? Like, for example, if there's some big project out there's like, we would love to move to Ruff, but there's this one plugin we're waiting on.
Yeah, I mostly hear about it in issues. And there are a couple issues where it's like, it's kind of a big GitHub issue. It'll be like, implement this plugin. And a lot of people will come and like give it a thumbs up or whatever. We have pretty good coverage now, actually. Like, there is a long tail. Like, there's a big ecosystem of like Flake8 plugins, and sometimes someone will come along and ask for a plugin that I haven't really like seen before, and then it's just a calculus of like, what do I want to prioritize? How much work is it? All that kind of stuff.
Is this a super easy thing to do? Like, oh, the line is too long. That's easy. Or is it, rewrite this? This generator in this other interesting way.
That happened with, a lot of people want like, I don't know how to pronounce this library, but like Darglint, like darglint. Darglint. I don't know. Anyway, it has a lot.
It's probably I would go with that as well. Yeah, Darglint. Let's go with that.
Yeah, it's very popular, but I've looked at the source. It's pretty complicated. So like, I need to, that's not something I can just like turn around in a day. But like, I hear like what people want, and some of those migrations though, I didn't even know about them until they'd happened.
Right.
Which is always cool.
Of course.
And then, sometimes, people come, they submit issues, I look at their profiles, I see what they're working on, I get a sense for what the projects are, right? So sometimes I know, and then I'm kind of fixing things knowing that hopefully it's unblocking them in different ways. But yeah, I mean, I think, like I said, I think the compatibility piece is like really huge. And I actually think that like Black and iSort and like the popularity of those things has made compatibility for me like a little bit easier because I can just like adhere to what they do. And then
Yeah, so many
there's
people
like
have
no code
centralized.
changes.
Yeah, they centralized around what, like Black is the truth, and then we'll debate beyond that. But like we're just going to accept Black because it's no fun to go commas on the end of the line, no commas on the trailing thing in the list. Like that. Those kind of debates just go on and on.
Yeah,
And
I know.
I think Black kind of solves that by just making a decision for you. And not everyone's totally happy with every choice, but it stops the debate, and that actually probably wins the day for most of them. One thing that's interesting here that I'm noticing about these projects in the large open source projects that have adopted Ruff, not all of them surely, but many of them like Pydantic and Polars and so on themselves are adopting Rust. Do you see synergy of those? Like, well, we're rewriting Pydantic core in Rust, like Samuel Colvin is, or the folks behind Polars are like, that's the core of it is about Rust, and that's the RS on the end, I think. So there might be a little extra draw there, right?
Yeah, I think it's just more like spiritual alignment.
Yes, exactly. Because it doesn't matter.
No, it doesn't.
but spiritually.
But there's a little bit of a bug. Bug in the sense of like once people start writing some stuff in Rust and improving their Python, they're kind of like more open to like, trying out other things that are written in Rust and so on. So that community has like been very interesting to sort of watch and be a part of, the like Rust Python community. It still feels like pretty nascent, but there are, but the tooling is actually like really great. And we could talk about that more, but like, there was definitely like a bunch of initial setup for actually like distributing Ruff on PyPI and making it pip installable. But now that that's over, it all like just works. And I wouldn't say it's like requires no effort, but it's actually pretty amazing, like how like the degree of integration and how much you can do now with these tools like Pyo3 and Maturin and some others.
Yeah. That was one of the things that was a really nice surprise for me as well, is how easy it is to install, right? Like, unless you told me, unless it wasn't part of, the elevator pitch, the little one sentence subtitle on the project, like you would know from a interacting perspective, which is kind of exactly what you want. I also think that there's some value to having these popular projects adopt Ruff, because Martin and the audience, for example, says, I found out about Ruff by looking to see what Fast API does, because presumably it's a ton of respect for Fast API and Sebastian, what his choices. So yeah, it's got to sort of create the snowball effect as well.
Yeah, I think like one thing that's a little bit overlooked about like why that adoption is useful is that it actually like feeds back into the project in like so many great ways. So, for example, like if Dagster adopted Ruff, and like they have like a really big like Python monorepo with like, I don't know, like 50 or 100 separate like Python modules or packages in there. And they filed like a bunch of issues around how can we make Ruff better for monorepos. And so now they can run Ruff once and it runs over all their separate projects that can all have their own configuration. And that's like a really, really powerful thing, and something that like, if I was just sort of sitting around like building Ruff, like I don't know that I would have known to prioritize that or what it should look like. And so like actually like working with people who want to adopt Ruff and like figuring out what stops them from using it provides like a ton of value to the project. And just prioritization. Like a lot of the iSort stuff, I I pushed on it a lot when I started, because Ruff does import sorting, so you can use it if you want in lieu of isort. And we implement a lot of the same configuration options, not all the same. Isort just is like really configurable, so we implement we sort of implement them as they get requested. But anyway, I prioritize that stuff because a lot of people wanted it, and they were coming to the issues and being like, "Hey, this would really help me adopt it." Blah blah blah. So just like getting the feedback and like hearing what's blocking people, like that itself is like so valuable for the project.
Right. And you have a lot of people involved in these larger projects, so they and they have specific polished needs, right? Like there's a lot of people who work on pandas or fast API, and those are mature code bases. It's not just a pet project, right?
Yeah, those are very mature. Yeah.
Yeah, exactly. That's good, but also it's a challenge. One other thing I would like to point out, you started off by introducing Ruff, saying, maybe people will be interested. I don't really know if they will. Maybe they will. That'd be cool. 6.5, 6.4 thousand stars. It's a non-trivial amount of interest. That's a lot of love. Yeah.
Yeah. And like, I don't know. One thing that I sometimes feel weird like highlighting all the big projects, because one thing that I really appreciate is just like anyone who's willing to try a tool like this.
Sure.
Like moving tools and trying new tools is like a big decision. And I just like really appreciate everyone who says nice things about it, or everyone who's like willing to give it a try, like no matter what they're working on. So it's nice to have a platform to say that out loud. So hopefully people hear it.
Yeah, absolutely. So the other thing I want to highlight about the repo here, not just the stars, but when I look at a project and I want to sort of assess, I really want to adopt this thing. Do I want to make this part of my dependencies or things or layers that I got to live with here? And if it goes sideways, I got to change something. Is, how old is the project? How active is the project? And so on. So, look, we started this podcast, 40 minutes ago. The last commit was 52 minutes ago to the repo.
Oh, yeah.
Which is,
sorry. Yeah, it's kind of.
That's awesome. I mean, you're like, what are you looking here? And it's yesterday. It's last week. I want to point out there's just a lot of activity. 78 contributors. It's a very lively project, and not just something that's cool, but there's a lot of interest and energy in it, which I think is a very strong signal that it's something people should be comfortable adopting.
Yeah, thanks. I appreciate you calling that out. I think, I guess a couple things. One, that's actually something that when I talked before about why would these big projects adopt this thing that like seems really experimental, that's actually something that comes up a lot. Is and I'm not in the conversation, but obviously I'm sleuthing a little bit on on the PRs, right? They're saying, well, it doesn't support X, but it's like really actively developed, and I'm like very confident that they will support that, at some point. And so like just like having something that is clearly very actively worked on, I think is quite like appealing and comforting to people. And I actually like do feel bad saying this, but like one of my not favorite, but it kind of an interaction that happens on the repo is someone will file an issue and they'll say, this is actually also a bug that exists in the, let's call it the upstream implementation. So the existing Python version of that tool also has that bug.
Like Pyland or Flake 8 or something like that.
Yeah.
Like, it does this, but we think it's wrong. We disagree with it or something, right?
Or there's an issue where, the maintainer is like, oh yeah, this is broken, right?
Yeah. Okay.
But, and it's really not like, the reason I feel bad saying it is like, like every project is different, and like every maintainer, like everyone's doing this like for free, right? Like I'm not here to like call out other maintainers, but I think it's a very satisfying interaction for people when, they link to an issue, it's been open for maybe for like years, and then I can actually just like fix it in like pretty quickly and ship a release in the same day. And like that, I think that's like a really like powerful thing that resonates with people a lot, is just the feeling of like, stuff getting shipped and like
Yeah.
things getting
Momentum.
fixed. And yeah, and like, you know, I'm working on this full time, so like I'm fortunate to be able to do that. And like I totally get it that like other projects just are in different states and stuff. But
Right.
I get a lot of value out of that, and people are always super appreciative, and so it all just like funnels into, you know, giving me energy.
Yeah. Eddie has called you a commit machine. Literally every time I update my project dependencies, I'm guaranteed to see new stuff on Ruff, on original
I
Ruff.
appreciate that. You know, I do appreciate that. I like, yeah, I do try to write a lot of code,
Yeah.
but you know, it's obviously
So
not just me. And like
yeah, of course.
the contributors have been awesome. And I think, I mean, one thing I'm particularly impressed by is just the number of people who, like, I don't even know if I always believe them when they say this, but like, just the number of people who are like, this is my first time writing Rust, or like I'm really not good at Rust, or like blah blah
And
blah.
here's something
And then they just
amazing.
like, yeah, and they just like make like great contributions. And they're like, hey, I'm
Yeah.
trying to learn Rust, and I obviously love that stuff. Like, if
Yeah.
people are interested in learning Rust, I actually think Ruff is like a great project and like a great place for that. But yeah, I mean, yeah, there are people who are working on stuff, especially the stuff that I just like it's like big things I can't like focus all my time on, and just like having great contributors who are like really, you know, like thoughtful and like prolific. Like, you
Mhm.
know, every project is lucky to have people like that.
How old is the project? When did you start it?
In August, so it's like
Yeah, so it not that old.
my time,
4, 5
my
months?
brain is like melting, but it's somewhere. Yeah, I think it's like somewhere between 4 and 6 months.
Mhm.
Sorry,
Did you say you're
I'm
working
not
on
doing
this
the
full
math.
time?
I'm working on it
As
full
like your
time.
full-time job?
Yeah,
Okay.
yeah.
And so how's that work? Is that GitHub sponsors, or are you employed by someone to completely work on it? What's the story? That sounds awesome.
Still figuring out. You know, I'll probably share more on that soon.
Okay.
I don't have
Yeah,
sponsors
yeah.
enabled right now. Still figuring out exactly like how I want that all to evolve.
Right.
But I am working on it full time. I don't anticipate that changing in any way. Like uh, I really happy and getting so much out of this, and you know, I think there are lots of ways to make it work. And you know, if not Ruff, I want to be working on like other Python tooling. So you know, I think there's like more stuff to come.
Okay. Well, it certainly is neat tooling. Let's go through the GitHub page here a little bit. So I think we've talked about the speed a couple times. We talked about ways in which that happens. You know, Rust is an important part, but it sounds like it's not the only reason that it's fast. You have a chart with the obvious like little asterisk caveat benchmarks
Yeah.
are
I
tough
mean,
to
you can
make
it's
meaningful.
reproducible, you know, like
Yeah,
all the
yeah,
stuff's
yeah.
in the README,
But
but
you're like,
yeah,
that's fast in this situation, but my situation is different, in which case, you know,
totally.
such and such, right? But for some large code base, we've got Ruff in 0.3 seconds, Autoflake at 6, PyLint at over 60 seconds, just barely. This is on the CPython code base from scratch, which is that's pretty ridiculous. And I already told you the numbers. I don't have a millisecond number, but it appears to be instant on, you know, 20,000 lines of Python code that I wrote. And it found some issues, which I thought would already be discovered. So that's pretty excellent.
Nice.
It's nearly Python 3.11, 100% compatible, right? You said the one major language
Oh
feature
yeah,
is the match statement, but other than that, it's compatible, right?
correct. Yeah. It supports
Okay.
um it supports some of the other language features like that are maybe less high profile, like the parenthesized with statements and stuff like that,
Mhm.
but it doesn't
Okay.
support the structural pattern matching yet.
Right. Got it. So it's got the autofix support, near parity with the Flake 8 rule set, which is cool. You talked about the way that you keep the performance fast, but still have
Yeah,
parity with Flake 8 is you have native reimplementations of the Flake 8 plugins.
that's right. Yeah. So we re-implement everything in Rust. And a lot of the time that's like me or whoever's working on it, like looking actually at the plugin and like the logic it uses and trying to mimic that in a high fidelity way. And often we'll like try to use the same test suite and you know, really try to make sure that we're compatible, except in cases where we think there's like an actual sort of factual error.
Yeah.
I think, you know, why Ruff is fast. The plugin stuff, there's a lot of interesting stuff to say about like the plugins because I think Rust is a big part of why Ruff is fast. But there are a couple of other big pieces. So one is that we take a lot of care in the code base to like only do necessary work, if that makes sense. So, you know, we support 300 something rules, but depending on which exact rules you have enabled, we'll skip a lot of unnecessary work.
Okay.
And that can help a lot. So, you know, it's basically tailored to how much you're using it. So like if you're not using it as an import sorter, you know, there's a bunch of stuff that we can skip is how I would think about it. But the other like really big one is because everything is sort of implemented in like one system, there's a lot of work that would normally be duplicated between a lot of different tools that can actually just be done once. So the way to think of that is like, if you look at like Flake8 with Flake8 doc strings is maybe one example, which uses PyDoc style. Sorry, I know it's like a huge, it's like a tree of tools. But you know, if you add that plugin, so PyFlakes is going to parse your source code and turn that into an AST. And then PyDoc style actually has basically its own parser that will go back over the source code and look at all the tokens and extract the doc strings. And if you have a bunch of different tools, like some of them will share that abstract syntax tree, but a lot of them end up doing work that other tools are also doing.
Right, because they can't count on necessarily that being done, or the plugin system doesn't provide work that's already been done to them, so they got to start over anyway, right?
Yeah, or they might want to do things in like a slightly different, maybe you have like 3 different plugins. Like I guess one example is a lot of different a lot of plugins like need some way to tell if a function is like public or private. And it's not like super complicated, but you know, it's not like totally trivial. Like you need to account for functions that are inside of classes. Like, is it a public method or a private method? You need to account for functions that are inside of other functions, right? So there's a lot of rules actually for like determining what's like public and private. And you know, you might have one lint rule that's like all public methods need to have doc strings, and you might have another rule that's like all public methods need to have type annotations. And if you have 2 separate plugins that are doing that, they both need a way to actually like extract that information. And you know, it's not necessarily the case that like it'll be way faster to do it with one pass and one. I think it will. It may not be like orders of magnitude, but the other thing is you have a lot of like consistency. So like, you know, it's defined in one way. You're not going to be at the whims of like small decisions that the tools had to make. For us as like maintainers and like building Ruff, you know, there's a lot of stuff you like don't have to implement multiple times. Like I can leverage that and like go and implement other lint rules, and I don't have to like figure out from scratch how do I determine like what's public and private? How do I like extract all the doc strings from a file? Like we already have all that infrastructure. So there's kind of like,
I see,
economies of scale, I guess, to like implementing new stuff. Like, you know, it sort of snowballs a little bit. Like the tool gets more powerful, it gets kind of easier to do things.
Yeah.
I mean, I think you'd be surprised like how much of building a tool, I don't know about you personally, but like I was surprised by like how much of building a tool like this is just there's like settings and like configuration and like how do people express their settings? What does the command line interface look like? How do you find all the Python files in a directory? Like, it sounds trivial, but like, do you also want to respect like Git ignores? Do you want users to be able to ignore files? Like, there's a lot of rules. And so again, it's like, if I look at a new Python tool, that wants to go off and implement something, they might have to implement all that stuff themselves. But for us, it's like we have all that infrastructure in place. And so if we want to build a new piece of functionality, it's just sort of defining the rule, and we get all this other stuff for free.
Yeah, you can definitely build on the layers that are in place because it's all together. It's cool.
Yeah.
All right, let's look through here a little bit. Like I said, there's the testimonials from the different projects, like Brian from Bokeh or Sebastian from Fast API and whatnot there. But let's start with installing it. Like I said, you would know that this wasn't just a Python tool you could use. Pip install Ruff, that's the way to go. But when I installed it, I didn't pip install. I pipx installed it. Are you a fan of pipx?
Yeah, I use pipx.
Yeah,
that's great.
To me, it seems like Ruff is something I want to run on different projects, and I just kind of want Ruff in my tool set. And so I pipx installed Ruff. What do you think? Good idea? Is it better to put it, say, like in a per version at per project?
Like everything, I think it probably depends. But yeah. I mean, I definitely install a lot of stuff with pipx. I think the one issue with Ruff, and I guess I recognize why this can be annoying for some people, for sure. Like, we release a lot, and so if projects don't pin their dependencies, then they can start to see like new errors as we add new rules. Which I guess in some sense is like a breaking change, but I don't really consider it as such. It's like, they have, it's like they have the like, let's say they have the like flake8 simplify rule set enabled, and we add a new rule and that gets turned on for them. So anyway, the point is, like, people, I guess I recommend pinning Ruff if you're using it for a project, which, I mean, with pipx, you're just going to stay on one version.
Right, until you run pipx upgrade dash all or whatever, or upgrade that thing. Yeah, exactly. So in a sense, it's kind of a pin, but it's pinned globally and it gets upgraded globally, and that not per project.
Yeah.
For me, that's kind of okay. But if I was on a large team, lots of people who are working on it, you might want to control that more. I can see that.
Yeah. So we have a homebrew distribution and a Conda distribution on CondaForge, and then I did those, and then there's everything else was done by other people. So I'm like, which is cool, but also means I'm like less familiar with them.
Yeah, sure.
I mean, I don't know, publishing on homebrew and CondaForge was like a pretty interesting experience for me, actually, because I've never done that. And I didn't actually really know that much about how those worked. So that was cool. Hopefully it's useful for people. There's definitely some complexity with like the packaging and release stuff, which I don't know if you want to talk about that or not, but because we're building Rust, there's like a couple things that we need to do that are a little different from a standard Python package.
Maybe just touch on it a bit, because what you deliver is a wheel, right? But it's got the compiled Rust bits for me on my ARM64 Mac OS build, right?
Yeah, that's right. So basically it just means we have to, the wheel is a sort of pre-compiled version of the package, as opposed to just giving you the source code. Like, if I just gave you the source code and not the wheel, you'd actually need to have Rust installed, because you'd have to actually build the thing and install it. Which is, of course, an extremely unreasonable expectation for the kind of people who are using this for the most part.
But before the wheels really became popular, that was part of the step, right? It would just build for you.
So
or it wouldn't build for you, which was frustrating, but that was part of the step, right?
So basically, we just build wheels for all the platforms that I know of.
Is it all CI/CD? You just push it to some branch and magic happens, and then wheels start appearing in places.
Yeah, that's right. So whenever I cut a release on GitHub, like, I just use like GitHub releases, basically, or I just use GitHub releases. It kicks off a release job, and then that's all through GitHub Actions. So it just has a big matrix, right, of all the different operating systems. we only have to build, thankfully, we only have to build one wheel per operating system. We don't have to build one wheel per Python version, which is something that can happen sometimes. And then you have like a mass explosion of number of wheels. But that's all facilitated with a tool called Maturin, which I'm a big fan of, which is, it's sort of like, I don't know, like setup tools and a bunch of other stuff bundled together, but specifically for shipping mixed Rust Python projects. So I don't actually really have to like do anything for the most part to make that work. I just, my PyProject.toml has, you know, Maturin at the top, and I have a Rust project, and I call it Maturin build, and it creates a wheel. So it's all like, I don't know. I think it's like super cool. That works.
Yeah, that sounds sounds super smooth and super neat. Yeah, and like I said, as a consumer of it, also very smooth, right? It was installed quickly. I didn't have to wait on some build. I didn't need build tools or config that I don't care about or don't use. I'm pretty sure I do have Rust, the Rust C as a CLI option I can use here, but you know, you don't want to depend on that, right?
No.
So you run it on the command line, you say Ruff, and you point at either a file or a directory or some pattern of files, right? Some star type of thing, which is cool. And that gives you the output. You can also do it with a -- watch and just run it constantly, which is pretty cool, right? It's fast enough that basically as you save it, if there's problems, that'll just appear in the terminal, right? Or wherever you run it.
That's kind of a funny example because it's a good example because I'm pretty sure I took that exactly from probably from TSC, which is the TypeScript compiler. They have a watch setting, and I like how it works, and so I wanted that for Ruff. So it's just that's a very literal example of me looking at another tool from like another space and being like, oh, that's really nice. And I
suspect it's not terribly difficult. Yeah, I suppose it's not terribly difficult to implement, right? You take the pattern and you put a watch in the OS, a watch implementation, and you say, call me back when something changes, and because it's fast, it just reruns, right? But it's still
that's exactly right.
It's very handy though that it's there. The other thing that's interesting is you can do it as a pre-commit hook, which is nice.
Yep. Yeah, that's that works pretty well for people. I think a lot of people seem to use it. So I'm glad that it exists. It's a little bit of a weird setup because maybe it's actually not that interesting to talk about, but it's in like a separate repo for sort of like complicated reasons that I can't even really remember.
Okay, interesting. Now, to configure it, it has a, let's say, comprehensive CLI set of options. You know, I can't remember, maybe 15 or so command line options you can pass it, but you can also put it into the PyProject.toml with things just like tool.ruff, and then you can put your various settings in there, right? So it just sort of integrates along that, or you can have a ruff.toml and then put it in there.
So that's something that I took basically from Hatch. So within Hatch, you can have a PyProject.toml or a hatch.toml, and the hatch.toml kind of like unnests the configuration. Like if you use a ruff.toml, you don't need to have like tool.ruff at the top and stuff like that. I think one thing that I'm quite happy that we have is like the configuration is very like type safe. So if you try to like, you know, so that line select equals EF, those are like error, like rule codes that are defined in Ruff. And so if you replaced F with some string that wasn't, you know, a real rule, you'll get an error immediately saying that, you know, your PyProject.toml was invalid in like these ways, blah, blah, blah.
Interesting.
And similarly, we also, we create what are called like JSON schemas for the configuration. So if you're in PyCharm and you open up like a PyProject.toml and you type tool.ruff, it'll actually like show you all the options, and it'll actually surface the documentation we have for the options too.
Oh, nice.
Which is pretty cool. Yeah. So I'd like more tools to do that because I think it's like super useful. I think Poetry has it, but not too many others do. You can get it in VS Code as well, but you need to install an extension. It's called like Even Better Toml, I think.
Right. Okay.
But I'm happy with those things. I think it makes it like, I think small things like that add up. And I'm glad we were able to do them.
Yeah, when I looked at the configuration settings, like the exclude directories and various other things, like that's kind of a lot to put on a command line. It would be nice if you could just put it and say ruff.toml or pyproject.toml, and then when you just type ruff the thing, it sees that and it uses it, right?
Yeah, and
Nice.
yeah, I've kind of like intentionally like not put a lot of these arguments on the command line, like for that reason. Like you could imagine taking everything here and exposing it on the command line, but the command line really just deals with like how should the thing execute and not like, I don't know, what should the max complexity be of the cape complexity check and stuff.
Well, I think that's fair. Like put the common stuff on the command line and then say, and if you need to go crazy, here's your -- config. Pass that in and put it in there, right? Yeah. Sorry, 1 second. There you go. One thing that I did want to talk about, and you kind of touched on, there's a bunch of the command line arguments. One of the things I did want to talk about is the editor integration. There's a huge bunch of rules here. We got to scroll through on the homepage to get down to it, which is awesome. No, it's good. I mean, these are like all the things it checks that I don't have to think about anymore, which is great. Eventually, though, geez, I forgot it was this long. Eventually, though, it has plugins, or maybe that's not quite the way I said. It has an extension for VS Code, and it has ways to basically add it as a command to PyCharm, right? Which is those are both awesome editors that are kind of very friendly to thinking about code formatting and exposing the errors that this would as well. So that's great. You might want to just talk about that just real quick.
Yeah, totally. So yeah, we have a VS Code extension. So that was my first time writing a VS Code extension. Actually these extensions use or they conform to something called the language server protocol. Effectively, that's sort of like a standard. I believe I'll probably get like a bunch of the history wrong, but I believe it's Microsoft that like publishes and maintains that spec. The nice thing about that protocol is you can actually use like almost all of the code behind the VS Code extension is actually published as a language server. Yeah, Ruff LSP. What that means is you can actually get like the exact same behaviors in all sorts of different editors. It's not confined to VS Code. So if you use like NeoVim or like Sublime Text or whatever else,
right,
those all support this standard protocol, and they all have ways to tap into that Ruff language server protocol. We have sort of like the standalone LSP, which we have instructions for like Sublime and other tools. And then we have the actual extension, which is published on the marketplace. Those are things I definitely want to like keep supporting, and I view them as like official arms, right, of the project, which I think is nice. So people should know that like, those are official and like I fix bugs in them and all that kind of stuff.
Nice. And then for PyCharm, you just add it as an external tool, and then you have the Ruff command around. Or for both of these, if you prefer, you just add it as a pre-commit hook.
Yep.
That's also.
Yeah, that's right.
Yeah, that then like as you interact with it, it'll run the pre-commit hook as well if you try to check things in. All right, yeah, super cool here. I think this is a neat project. I ran it as my project, and I thought, everything is pretty much good to go. Where when I'm using PyCharm, for example, it'll often tell me many of these things. Like it'll say there's a local variable that's unused, or it'll automatically remove unused imports. And yet I'm looking at 331 Issues 108 are potentially fixable with the --fix option. So that sounds like there's still a lot of value to like make that part of my tool chain.
Yeah, I mean, and feel free to have some of your own opinions about which of those rules actually matter.
Sure, and I suspect you can disable them in your config file, right? You can say this rule I don't care about. Okay.
Yeah, and this is another sort of compatibility thing. Like the API for actually like turning rules on and off is like essentially identical to the Flake8 API. So that's also
no
useful
QA,
for people migrating over.
Is it the like comment no QA is one option?
Yeah, we respect those too. We also respect like isorts action comments. So we like do a lot of stuff to try and maintain compatibility.
Nice.
Maybe another like interesting thing in that vein is that we ship a tool called Flake8 to Ruff, which does sort of what it sounds like. So you point it to a Flake8 configuration file and it spits out TOML for Ruff, that's compatible. And it also tells you if there were things in the file that we don't support, which is useful too. Like, oh, hey, you're using these rules. Those actually aren't implemented yet. So that's also maintained as like part of the project. So, recommend checking it out.
Excellent. Well, Charlie, I think we're getting short on time, but not short on topic. There's a whole lot more to dive into. I think it's a really cool project.
Yeah,
I think it's neat.
Are we gonna do a big WASM section? No, I'm kidding.
Yeah, I mean, we could do a WASM section. We even have some great ChatGPT questions in the audience. But I don't necessarily think that there's time for those, unfortunately. But there is one final question that I want to ask that's kind of inspired by the audience, but I think it's good for everyone. Jean Gabriel asks, is there a roadmap or timeline for Ruff development out there? Like, what's next, basically?
Yeah, totally. So there's no, like, I guess the short answer to that is no. Like, there's not like a published timeline, unfortunately. Like, most of this stuff exists in my head and in issues. Like, everything happens on issues. Like, we're just talking a lot on issues. But I'll maybe talk a bit about like the things that I'm thinking about. So one is fixing like the structural pattern matching issue, and so like getting full like Python compatibility, which it's sort of like one bug, but then unlocks us doing what I hope will be like a stable release, even if that's not that much changes and it's just kind of the marketing of it. But hopefully we'll fix that and then we can do like a stable release. There are two other kind of big things on my mind. So one is this is like a really big project, but not Ruff, the thing I'm about to talk about. But I want to extend Ruff to do like full code auto formatting, so that people could use it in lieu of black if they wanted to. I think it's like a really natural fit for what Ruff is doing, and a lot of people ask about it. So the way that will, there's an issue where we talk about this like on the repo. It's not like some big secret reveal, but the way that I think about that, like with all things, is I want it to be like sort of incrementally adoptable. So like right now you can use Ruff with isort, or you can use just Ruff, or you can use Ruff to do your input sorting, but like not as a linter. Like you can kind of pick and choose like what you want to use. And I view like the auto formatter is the same way. Like I fully expect that people will keep using Ruff and black. But it's just like the kind of functionality that makes a lot of sense given what we're already doing and like the way that the project's evolving. So I need to be careful because like it's like that's a lot of work. And so I'm not like saying exactly when that will be done, but I do want to start working on it. And then the other thing, which is maybe like a little bit less exciting to other people, is like, I think at some point I'd like Ruff to get to a world where it kind of stands alone a little bit more and isn't viewed quite as much as a compatibility, as this compatibility layer. Like right now, all the rules kind of map back to Flake8 or other tools. And when you're using Ruff, you're kind of thinking in the mindset of those other tools, like what are the rules and how do I configure them? At some point in the future, I'd actually like Ruff to sort of have its own API and like own indexing of the rules, and to view that as kind of a compatibility layer that will not go away. Like this won't put a burden on users, but I'd like to get to a point where like conceptually a lot of this stuff is like first class in Ruff, and it's not viewed as re-implementations of other extensions, which I think will enable us to do a lot of cool things. But I'm hopeful that I plan on doing that in a way that has no disruption to users. So
right,
we'll continue to support the existing API and such. Yeah,
exactly. Very exciting. Very exciting. Well, congratulations on a project that people seem to love. It's got a lot of traction and definitely doing some cool stuff. So before we get out of here, though, final 2 questions. If you're going to write some Python code, what editor are you using these days?
I use PyCharm for everything. And that includes Rust. So I do all my Rust and my Python in PyCharm.
Nice. Is there a cool plugin that basically adds Rust support to?
Yeah, there's just there's an official IntelliJ Rust plugin.
Got it. Nice.
Works really well.
Yeah, I haven't tried. I've used IntelliJ for like that platform for Dart and Flutter, but I haven't tried to plug Rust into it. But yeah, it does do a lot of things. Cool. And then notable PyPI package, something out there. You've named a couple that do the Rust integration nicely, but anything you want to give a shout out to?
I really want to give a shout out. I've already mentioned it a few times, but I think if you're interested in doing Rust Python stuff, you should really look at Matrin.
Matrin, all right.
Matrin. It's just it just like makes the publishing really easy, and you still have to learn Rust, which is not easy, but I do. It's worthwhile, I think, but it's not easy. But it makes the publishing of Rust code to PyPI, really easy.
Yeah. Awesome. Well, great recommendation. Thanks for being here. Final call to action. People want to get started with Ruff. What do you tell them?
Sorry. Well, I think the main thing that I would like to say is like, if you're interested in contributing, even if you don't know that much Rust and are interested in learning, like I'd love to, see you on the repo. And I hope it's a place that people feel really welcome to like come and contribute, even if they aren't 100% certain if their code is right or anything like that. So definitely really excited to have more contributors and have more people coming into the project. And of course, you should also try using it yourself.
All right, excellent. Well, thanks for being here. It was a great conversation with you.
Yeah, thanks so much for having me. It was a really cool opportunity. Appreciate it.